Okay, student, in this method we have to find probability by using a standard normal probability distribution. For if we are going to find greater than probability, x greater than, for example, 790, first we try to convert 1 minus x less than equal to, because the CDF table or standard normal distribution table Z can never provide probability greater than something. So first we try to convert into the less than, then convert x into the Z as usual in the previous, for example, slides, and after converting Z, count the value, see the value by help of table of standard normal distribution, and subtracting 1 minus, you can get the probability. Now student, in this way we have to make, or we can perform graph as well and show these area under the curve of standard normal probability distribution. For example, if we are going to make the graph of this, for example, first we are going to find probability x less than 790. So anybody says that what is the graphical area? So for example, make a for example standard normal distribution with mean 0, z. This is the graph of z. So and after that, uh, see where the x converted into the z. For example, this is z, x converted into the z. What is the value? Minus 2.10. So where is minus 2.10? From the left side of this graph, 2 point minus 2.10. So this is search the minus 2.10 in this graph, for example, and see the sign less than or greater than. This is only less than symbol. So write shaded all left side area. Less than stand for all left side area, shaded all left side area, because the less than symbol shaded all left side area. In this graph, this is the graphical view, show that this is the 0.01 probability. So you may also make just like sketches or graph example in this question. In this question, for example, how we can make graph of certain, for example, probability. First make simple normal distribution and say 0 z. We always make a graph for standard normal distribution. So after that, make a standard normal distribution. Now see this one. What are the step? Who is the step to convert z? For example, this one. See the value minus 2.10. Mark the minus 2.10 from here. This is minus 2.10 again. Now student, this shows that probability z less than. So in eventually, for example, we are going to shed the left hand side region, but 1 minus, this is what we call probability greater than. So 1 minus probability z, this is the red, this is the, for example, I shaded this region. This is what we call probability z, this one less than minus 2.10. But we are going to find finally 1 minus this probability. 1 minus probability z less than this. So 1 minus stand for the this black color shaded region is not the actual region, because this show that less than probability. We are going to subtract 1 minus probability. So in all other remaining right side area, for example, all remaining right side area I shaded into the different color, for example, red color. All right hand side area represent the probability greater than. This is the graph of this function, for example. So this represent probability x greater than 790. So student, this is what we call 790. Okay, so in this method you can make graph very easily. You can make graph by help of table, by help of calculation, for example. Okay, so this is what we call standard normal distribution, how we can find probability by using standard normal probability distribution. So solve all these remaining numericals and much more things we discuss further in the live session and calculation. Okay, so now we are going to start the second part of this lecture number 8. Actually, we are going, this is all practice numerical students. 6.12 Walpole and Myers book, 6.12 on exercise 6, 6.13, 6.14. So this is what we call standardized normal distribution. By help of normal distribution, first we convert into the z, and then find probability by help of table, and also we discuss the shaded region area or making a graph or shape of distribution. So student, we are going to start another chapter of our course. This is what we call regression and correlation. Now we discussed in the previous slides the standard normal area under the curve. By help of standard normal distribution, we can find probability of several events for converting the normal distribution into the z, for example standard normal probability distribution. And after that, the next topic, this is the actually chapter number 11 of our course, regression and correlation. So we are going to start the learning object. First of all, we discuss what is the correlation concept, what is the simple linear regression, how we can find regression model, estimated linear regression equation, regression example, for example coefficient of determination and coefficient of correlation. So these are main topics of in this chapter. So these are these are main topics of these regression and correlation. Actually student, in regression, simple linear regression model, we discuss two variables, and for example we are going to relate any two variables, selling price of a home and its size. Is there any dependency between selling price of a home and its size? For example, amount of advertising expenses and amount of sale, for example daily temperature and daily water consumption, for example undergraduate GPA and starting salary of graduate. Is there any dependency between them, or which one is independent variable and which one is dependent variable? Weight of automobile and miles per gallon, for example. So these all are example of simple linear regression model. Actually, what is the regression model? In regression model, we discuss we predict value of one dependent variable by help of one or more independent variables. So we can write as, for example, see this one. So students, see this one. If we are going to predict value of one dependent variable, by using one or more independent variable, we use a statistical procedure called regression model. So this is the actual definition of regression model. If we are going to predict value of one dependent variable, remember one thing, dependent variable must be a one, but independent variable may be one or more than one, for example. So these are underlines. For example, in this scenario, the value of one dependent variable, there is only one dependent variable, but we have one or more independent variables. So this is what we call regression model. So in regression model, we always predict one dependent variable, but the independent variable may be one or more. Normal circumstances independent variable also equal to one. So in this way, see this, selling price of home and its size. Size is the independent variable and selling price is set to be the dependent variable. So one more thing I repeat once again, students, dependent variable always being a one. There is no any cost of example, there is only two, in some circumstances there are two dependent variable. No, dependent variable always being a one, but independent variable may be one or more than one, for example. So these are examples in which dependent variable also one and independent variable exactly also equal to one. For example, amount of advertising expenses, this is the dependent variable, and amount of sales, this is the independent variable. For example, daily temperature and daily water consumption. So depend upon temperature is a, for example, independent variable, and water consumption is a dependent variable. Undergraduate GPA, your result, and starting salary. So in this way, one dependent variable and another one of a independent variable, for example. So this is what we call linear regression model or simple regression model. So there is another definition: regression analysis can be used to develop the equation. This is the model equation. There is only model, make a model in which one dependent variable and also there is only one independent variable are there. So in this way, the variable being predicted is called dependent variable. Those variable are going to be predictor variable is said to be the dependent variable, and it is denoted by the y. For example, dependent variable is denoted by y, capital Y, small y. Okay. Now independent variable, the predict the value of dependent variable is called independent variable, denoted by x. So independent variable is denoted by the x. Okay, so these are notations. Dependent variable mostly denoted by the y, and independent variable denoted by the x variable. Okay, so this is what we call linear model, simple linear regression model. Student, next one, simple linear regression model involve one dependent variable and one independent variable. So this is also important line, one independent variable and as usual one dependent variable. One more thing, students, dependent variable may be more than dependent variable always being a one. So student, this is a regression model in which linear regression model there is only one independent variable and as usual dependent variable always equal to one. The relationship between two variable is approximately straight line. In linear regression model, the relationship between two variables, whether dependent and one independent variable, is said to be the, for example, straight line, just like that. For example, this is independent variable and we are going to plot dependent variable always y-axis. So the relation between always being a linear, all these points lie on the straight line. Now student, regression analysis involve two independent variable. If we have two or more than two independent variable, then this is called multiple regression model. So this is another type of regression model. There are two types of regression model. Number one, linear regression model. For example, in linear regression model there is only one independent variable but and dependent variable always being a one. But in, for example, multiple regression model, there is two or more than two independent variables. For example, independent variable, in multiple regression model there are two independent variable or maybe more than three independent variable, four independent variable. But in regression, in multiple linear regression model, the dependent variable is one, dependent variable always being a one, because dependent variable can never be more than one. So independent variable may be one or more than two, for example, independent variable. So this is what we call multiple regression line. Now we are going to start first of all simple linear regression model. So first of all we are going to start simple linear regression model. So students, see this one. This is the simple population linear regression model. Y is equal to beta naught plus beta 1x plus ei. E, for example, epsilon, you can read very easily, and in the past history or in mathematics you can read epsilon. We read e errors. For example, beta naught and beta 1 are called parameters. So equation, student, this is the simple linear equation. For example, beta naught, we can say that b naught plus beta 1, we can say that b1, and x and plus ei. For example, we can write e as ei, epsilon is a ei. For example, students, see this one. This is exactly same equation you read in the inter classes. For example, y equal to, for example, mx plus c. For example, slope intercept form. So we use mx plus c instead of b1x, for example, see this one, and plus c in place of plus c equal to b naught, and one more extra thing involved, ei. So we are going to discuss what is e. Beta naught is the said to be the y-intercept, beta 1 is the slope, coefficient of x is the slope, similar equation which I already write in above page, for example. So this is actually slope intercept form, simple equation of linear equation of a straight line. Beta 1 is said to be the slope and beta naught is said to be the y-intercept. Okay, so these are two parameters involve the simple linear regression model. Ei is the random variable called error, where ei is said to be the error, or some people said to be residual. Now we are going to discuss what is residual. See this one, student. If we are going to plot this equation, for example, this is the graph I make instead of, for example, in other graph. For example, see this one, x-axis, for example, this is y-axis. Take values of x in the x-axis and take value of y in line of y-axis. Now plot these, for example, line, simple straight line. Let's suppose to be this is the equation, y is equal to beta naught plus b1x. Okay, population linear regression model. Now student, the original point of the data may be lie on this line. For example, these are original point I place into the for example, red color, original point. These are original points. Some points lie on this line, but most of the point, for example, see this one, lie outside the line. So see this one, these are all point lie outside the line. So student, this point lie must be this line, but unfortunately outside the line. So the distance between this point and the line, for example, see this one, student, the distance between this point to the line is said to be ei. I represent the graph much for example, visible form. For example, this is population regression model, this one, and some points lie outside the line. So student, the distance between these point to line is said to be ei. Another is said to be ei. This is another ei. So see this one in the printed graph, ei, what is the ei is said to be the, for example, this is the point xi comma yi. So the distance between this point and this line is said to be ei. Unfortunately, because all points must be lie on the straight line, but some of the points lie outside the line, above the line or below the line, for example, not on the line, for example. So in this way, the residual or errors must be present, for example, must be appear. In this way, residual and errors must be appear. So we are going to minimize this residual, students. We are going to minimize this residual, must be minimized such that these all points lie on the straight line. So in this way, this is the graph, see this one, for example, we change the equation y equal to b naught beta naught plus b1. Instead of we write y is equal to b naught plus b1x. This is what we call estimated, this is equation, student, estimated linear regression model, estimated linear regression model. So how you can estimate, put beta naught, replace beta naught by b naught and replace beta 1 by b1, just simple to make this equation. So student, make a graph. If we make a graph of this equation, for example, this is by equal to b naught plus b1x. So this is a straight line, but some of the point lie outside this line, see this one. So the distance between this point and this line is said to be the ei. Now we are going to represent small ei because this is the estimated linear regression model. So distance between point and line is said to be EI. Distance between point and line is said to be EI. So there are so many EIs are there. This is what we call EIs, errors, the distance between point and line. Okay, now we are going to minimize, students, we are going to minimize this error. So these all are alphabets representing abbreviation, doesn't make any situation. For example, positive linear relationship, in this way you can obtain, if slope are positive then the line must be, for example, is in this direction. For example, if slope is negative, beta 1 negative, for example, line plot in this line in this direction, for example. So these are direction of linear regression model. If slope is zero, if slope is zero, you all remember that the line is parallel to x-axis. So these are three qualities of regression model. So student, this is our main equation. Y cap, why we are going to make a cap, for example, instead of this, for example, y cap instead of y cap is equal to, why we are going to uh, show y cap. Y cap stand for predictor, estimator. Y cap equal to b naught plus b1 x. Student, this is the estimated linear regression model. We replace beta naught, we replace, see this one, replace beta naught by b naught and b1 by beta 1 by b1. So we can obtain this regression model. And where is EI? EI is not there. Where is EI? Because EI going to be minimized. Where EI is going to be minimized. How we can minimize EI? See this one, student. First of all, we discuss this population linear regression model. Then we have data. Then we have going to be estimated linear regression model by putting beta naught to b naught and beta 1 into b1. And then b naught and b2 are the two estimator of beta naught and beta 1. For example, this is the estimator, and how we can find the estimator? By using least square criteria. Student, least square criteria is the, we are going to minimize summation yi minus y cap whole square. What is y cap? Y cap is the estimated value. Estimated. This is actually the estimated value. Okay, and yi, only yi is the observed value. Observed value. So these are two difference between them. If we are going to take difference between observed value and expected value, estimated value, and take the square, and after find the sum, this is what we called EI. Student, this is the formula of EI. EI is equal to yi observed value minus yi cap estimated value. If we are going to take square of these EI, for example, this is what we have, EI square and sum, find the sum of this bracket and find minimum value, then this is called least square estimation. By help of this method, we do not read this method because this is very lengthy and pure statistical method. We discuss how we can minimize yi minus yi cap whole square. So errors, we must minimize sum of square of errors, EI must be minimized or must be equal to 0. If we are going to make sum of all EI's square equal to 0 by using this method, least square method, then becomes equal to 0, then the equation of for example this one, how becomes equation of estimated linear regression model? This one, plus EI is equal to 0. So first of all we write y cap equal to b naught plus b1x and plus EI. Now by least square method, what is the least square method? Say that summation of EI square must be equal to minimum or 0. So this must be equal to 0. EI must be equal to 0. So what is the new equation? Becomes y cap equal to b naught plus b1x. This is what we call estimated linear regression model. Here we represent estimated linear regression model. So student, this is the theoretical points of linear regression model. How we can estimate where is EI. EI is the residuals, the difference between this is the difference between, see this one, this is the difference between observed value and expected value. This is what we call EI, and we are going to minimize this EI such that these are formulas for finding B naught and beta 1. See this student, B naught and beta 1. So we are now going to replace B naught and beta 1 by help of this formula, for example, by help of this method. So this is the formula in which we are going to represent, for example, y cap is equal to B naught plus B1x. Now let our convenient B naught is equal to A and B1 is equal to B, for example. So what is the linear regression model becomes? Y equal to A plus Bx. Simply A plus Bx is the slope intercept form. So now student, you remember this equation. This is the estimated linear regression model. This is the estimated linear regression model, and we need the value of A and B. B is the slope, A is the y-intercept. These are values for finding, these are formulas for finding values of A and B. So, and how we can derive? By using least square method. All these formulas are derived from the least square method. So another point, we are going to replace beta B naught and B1 as well. B naught supposed to be A and B1 is supposed to be B, such that equation becomes a slope intercept form, simple slope A plus Bx. It is not necessary you make this equation, you remember this equation, for example, beta naught and B1. So instead of this formula, if you, for example, follow this equation, estimated linear regression model, the formula becomes, for example, this is not B, this is the formula for finding B1, and this is not A, this is the formula for finding B naught, students. Okay, so you remember this equation. This is the estimated linear regression model. Linear, one dependent variable and one independent variable are this. So B naught and B1 is the two parameters. So and those two parameter can be found by help of this equation. So B naught and B1 is the two parameter. For example, B naught is equal to, supposed to be A, B1 is equal to B. Now the equation becomes y cap equal to A plus Bx. Now find the values of A and B by using these formula, simple formula, summation xy covariance. This is what we call covariance of xy, and denominator is denoted by variance of x. And B naught or A is equal to y bar minus bx bar. Y bar is the summation y upon n, x bar is the summation x upon n. First of all, find value of B or B1, because the A formula, see this one, the formula for finding A, we need B. So first of all, we calculate this one, B or B1, for example. Student, if you have learned this equation, follow this linear equation, then you must change the alphabet. B1 is equal to and B naught is equal to this formula. But you remember A and B, for example, y equal to A plus Bx equation, then this is the original format or font in written in the form of A and B. So this is what we call simple linear regression model equation. So students, now second part of this chapter is said to be the correlation coefficient. First of all, we discuss how we can find the least square linear regression model. This is the least square linear regression model, in which we are going to predict the value of one independent variable by help of, we are going to predict value of one dependent variable by help of one independent variable. So another topic is said to be the correlation coefficient. Now what is the correlation coefficient? Correlation coefficient is a measurement of strength of relationship between two variables. This is what we call Pearson coefficient of correlation. Formula is that formula is equal to n summation xy minus summation x summation y, n overall square root n summation x square minus summation x whole square multiplied by square root n summation y square minus summation y whole square. This is denoted by R, English alphabet, for example. So Student, what is the main difference between correlation and regression model? Student, in regression model we discuss the value of one dependent variable by help of one independent variable, and we describe this model, for example model equation, to find relationship between them. But in correlation coefficient we discuss the strength relationship between two variables. There is only single value, they appear in the single value for by help of this formula, r is equal to point something, r equal to, for example, 0.29 minus 0.29. So this is the formula which you provide correlation coefficient. Or this is another covariance form. You can find covariance divided by under root variance of x and variance of y, or we can write standard deviation of x or standard deviation of y. So these all formulas belongs to correlation coefficient. Now what is correlation coefficient? For example, student, example how we can find linear. Yeah, one thing remember students, we always define a linear correlation coefficient. We always define linear strength between two variables. For example, see this one. For example, is there any relationship between weight and height? Weight is one variable and height is another variable. So student, in correlation coefficient there is no independent and dependent variable. There are two variables in which we are going to obtain the linear relationship or not. Is there any linear relationship or not between two variables? This is what we call correlation coefficient, for example. So for example, uh, foot size, another example, foot size and size of shoes, foot size and size of shoes. So is there any relationship between foot size and size of shoes? For example, foot size and size of shoes, any relationship between them? Yes, as many size of foot size, then the size of shoes also larger or smaller. So there is a strong relationship between size of foot and size of shoes, for example. Now is there any relationship between weight and IQ level of a person? IQ level of a person, is there any relationship between weight and IQ level of a person? No, weak relationship. Size of foot and size of shoes, yes, strong relationship. Weight and height, yes, strong relationship. So in correlation coefficient we use strength, measurement of strength relationship between two variables. And we always define linear correlation coefficient, student. We always define linear correlation coefficient. So this is what we call correlation coefficient, and Carl Pearson, scientist, one of the mathematician, described the formula for finding correlation coefficient, which is the following. See this one, Carl Pearson coefficient of correlation, you can write as covariance form. So in correlation there is a single value which they give us to provide what are the relationship between two variables, a strong relationship or weak relationship. Okay, so these are slabs, student, these are slabs for finding relationship. First of all, remember one thing, correlation coefficient are always lie between -1 to +1. This is the range of correlation coefficient. Correlation coefficient can never be greater than +1, can never be less than -1. It may be 0 and always lie between -1 to +1. So this is the range of correlation coefficient. The plus and minus sign used for positive linear correlation and negative linear correlation. So what is the plus and minus sign? Says that, see this one, student, if the our graph becomes linear just like that, having positive slope, see this one, so this is what we call positive correlation. And if our graph becomes like that, x-axis and for example y variable take on y-axis, and our graph becomes just like that, decreasing but linear, having linear graph, so we can say that negative correlation. Negative correlation. Okay, so these are two types of correlation: positive signs and positive said to be positive correlation, negative said to be negative correlation. Now if positive correlation, there is next value for exactly +1 is said to be the perfect correlation. This one is perfect correlation coefficient. And is the negative, if the value nearest to the negative, for example -1, it is said to be the perfect negative correlation. See this one. If our value is exactly -1 or nearest to -1, it is said to be the perfect negative correlation. Or student, if our value equal to 0, if r is equal to 0, then the graph is, what is the graph? The graph is equal to this form, not a straight line, not a straight line. This is what we call zero correlation, because we obtain negative correlation or positive correlation, just like that graph becomes a straight line. We always defined a linear correlation. See this one in the previous slide. The quantity r is the linear correlation. This is the formula for finding linear correlation, and linear correlation always lie between -1 to +1. Okay students, so these are further divided correlation slabs. Zero correlation, you can read what is the zero correlation. For example, if values, for example, just like that is said to be the positive correlation, just a straight line. All these points are very, by help of graph you can easily understandable of the correlation. If the graph just like that, then correlation equal to 0. Graph is just like that, see this one, negative correlation, it is said to be the -1, close to -1. For example, see this one, close to -1, this is close to -1. And if the graph just like that, see this one, r equal to 0.9, so we can write as close to +1, for example. So this is what we call the slabs of correlation coefficient. These are not important slabs, correlation negative, minus, plus 0.5. We can say that r equal to plus 0.5, moderate correlation. We can say that this is actually what we call moderate correlation. Okay, so students, these are different slabs for finding correlation coefficient. So this is the example in which we are going to find, first of all, linear regression model, and then find correlation coefficient and much more things. So students, in lecture number 8, for example, we discuss first of all different normal distribution, how we can find the value of normal probability distribution, and in this second topic we discuss the correlation and regression model, for example. So this is the correlation coefficient and definition of correlation coefficient. By help of this we can find the strength of relationship. So student, in lecture number 8 we discuss and how we can find probability by using normal distribution, by help converting normal distribution into the Z standard normal probability distribution. Then we find correlation and regression model. So these are theory. In lecture number 8 we discuss correlation and regression theoretical points and theoretical scenario. In next class we discuss in next lecture we discuss the numerical of regarding correlation and regression. So student, this is all about lecture number 8, in which we discuss theoretical points of regression model and how we can obtain the correlation coefficient. So in next class we discuss numericals and different points of how we can find a regression model and how we can obtain the relationship by using correlation coefficient between two variables. Okay, thank you. Allah Hafiz.